All right, we are still working here. So we are going to do number 13 in section 13.1, relative extrema. We're given a function y equals negative x cubed over 3 minus 2x squared plus 5x minus 2. Let's take the derivative. So that's going to be, so 3 times 3x cubed over 3. The 3's cancel out. We're left with negative x squared minus 4x plus 5. We have to find the critical values now. So we have to set this equal to 0. Factoring it. Let's factor out the negative 1 just to make it easy to factor. That gives us x squared plus 4x minus 5. So we have negative 1 times two numbers that add up to 5 and multiply to 5 and add up to 4. So negative 5 and 1 should do it. 5 and negative 1. So we have x minus 1, x plus 5. And so the critical values are going to be negative 1 and 1 and negative 5. All right. So now we need to identify the intervals in which the function is increasing, decreasing, and then that'll allow us to then identify the relative minimum or relative maximums if they exist. So let's set up our little chart here. We've got negative 5, 1. We've got the interval negative 5 to 1. We've got the interval 1 to infinity. And we've got the interval negative infinity to negative 5. Let's keep track of this negative 1 in this chart so that we get the sign right for the derivatives. We're going to look at x minus 1 as well and x plus 5. And that'll tell us the sign of the derivative, which will then allow us to figure out if the interval is increasing or decreasing. And thus help us identify the relative extrema. All right, so between negative 4 and negative 5, obviously negative 1 is going to be negative, regardless of what interval we're looking at. X minus 1, let's plug in negative 4. Negative 4 minus 1 is negative. Negative 4 plus 5 is positive. And so f prime of x is going to be positive, so it's going to be increasing on the interval between negative infinity and negative 5. Pardon me. All right, so now let's plug in 0 for this next interval between negative 5 and 1. 0 minus 1 is negative. 0 plus 5 is positive. So we're going to get, you know what, I screwed up this first part. I should have plugged in negative 6. Okay, so negative 6, plugging in negative 6 into the first one, x minus 1, that's going to be negative. Negative 6 plus 5 is going to be negative as well. So this whole thing is negative. So in the interval between negative infinity and negative 5, the function is going to be decreasing. Sorry about that. I could redo the video, but it's a lot of work. So I apologize for the mistake. Anyway. All right, so now let's plug in a value between negative 5 and 1. Let's plug in 0. We already did that, actually, and we found out that the first component, negative 1, is negative. Then we have a negative for the second component. So negative times a negative is a positive times a positive is positive. That means f prime of x is positive in this interval between negative 5 and 1, which means that the function is increasing. And that means that negative 5 is, let's write that up here since we have some room. Negative 5 is is a relative minimum. Alright, now let's look at the interval between 1 and infinity. Let's throw in 2. 2 minus 1 is 1, so that's going to be positive. And 2 plus 5 is 7, which is positive as well. So we're going to have a positive times a negative. That means this is going to be negative. The interval is going to be negative. That means the function is decreasing on that interval. And because it's increasing before 1 and decreasing after 1, we're going to have a relative maximum for 1. And there you have it. That is the end of that problem.